I hope this is stable. I'm hoping. Anyways, now we're going to find the coordinates of point MP1 when we're coming from EC1 and then MP1 when we're coming from BC1. How do we do that? Remember, we could have used this distance, but this distance, L over 2, this is L, né? Like the length of the curve. And then we can do that because the distance from here to here is not a straight line. So how do we find, oh sorry, now we're writing here. How do we find the, how do we find the value of D to when we're coming from here? We use the chord length. The chord length is the one that touches point MP1 from here. So the chord length has a formula. The formula for the chord length is equals to 2r sine delta over 4. And then where is delta over 4? Remember, this is delta, and then this small part left in between here is delta over 4 from where the chord length touches the curve. This angle here is delta over 4. So that is how we calculate, that is the D that we use for moving from this point to this point using this formula. So it's going to be 2 multiplied by R1, which were given in the question as 400 sine delta, which is, isn't, we've got delta 1, eh? And delta 1, we calculated it and we found that it was 32 degrees, 27 minutes and 33 seconds. So we say 32 degrees, 27 minutes and 33 seconds, all this over 4. That is how this is the distance from here to here. And then we punch that in our calculators. 2 times 400 is 800 sine 32 degrees, 27 minutes and 33 seconds. And then this is over 4. And then we close the bracket, which means that our distance, our D in this case, is 112.925. And what is our theta? Our theta, it's going to be, this is theta 1 that is moving in this direction. Eh? This is the forward bearing. And then our chord length is in, it's like this. Eh? So what we want to do is find this theta over there. What is that? It's theta 1 minus delta over 4. So we say theta 1, which is 292 degrees, 42 minutes and 44 seconds, minus delta over 4, which is 32 degrees, 27 minutes and 33 seconds, all this over 4. The answer that we get, that is our bearing from what? This part in that direction. So the answer that we are going to get is 284 degrees, 35 minutes and 51 seconds. That is our bearing. So we come with it here. We come and fill in our tables. We said our D is 112.925 and our theta, we just calculated it now, which is 284 degrees, 35 minutes and 51 seconds. And then we do the same thing. D is 112.925 sine theta, 284 degrees, 35 minutes and 51 seconds. And the answer that we get is a negative 109.2.280. And then for dx, we come and change sign and write cos here. And then the answer is 28.460. Now for us to find the coordinates of MP1, we say this negative 22298.908 plus a negative 109.280. The answer that we get, which is the coordinate of MP1, is 22408.188. And then the coordinates of MP1, the x coordinates, we say 35,158.192 plus 28.460. The answer that we get is 35,186.652. Now we're going to find the coordinates of MP1 when we're coming from EC1. How do we do that? So first, we're coming from here and we're coming back here. What is the back bearing? First of all, isn't the forward bearing is theta 2? So what's the back bearing? The back bearing is theta 2. Where should I write? Let me wrap this. No, let me just write it here. Our forward bearing, which is theta 2, is equals to 260 degrees, 15 minutes and 11 seconds minus 108. What are we looking for? We're looking for the back bearing. So the answer that we're going to get is 80 degrees, 15 minutes and 11 seconds. This is the back bearing, right? Back bearing from where? The back bearing from here to here. But that is not the value that we want because this is in this direction. Tina, we want this angle here, which is still this over this. But this time, we are not subtracting it because we're moving in this direction, which is a clockwise. If it's clockwise, we add this side, we subtract it because it's what? Anti-clockwise. We subtract, okay? So what do we say? We say our back bearing, which is 80 degrees, 15 minutes and 11 seconds plus delta over 4. So it's going to be 80 degrees, 15 minutes and 11 seconds plus delta over 4. And delta over 4 is 32 degrees, 27 minutes and 33 seconds over 4. The answer that we get is 88 degrees, 22 minutes and 4.25 seconds. This is our theta. So we come and write it here. 88 degrees, 22 minutes and this number of seconds. And then what is our D? Our D is from here to here, and since MP is in the middle from here to here, from here to here, which means the distance from this to this is the same as the distance from this to this. That's why we use 112.925 as our distance from the previous one because it's the same. Now for dy, we do the same thing. Our d is 112.925 sine theta, which is 88 degrees, 22 minutes and 4.25 seconds. The answer for dy is 112.879. And our answer for dx, we just come here and change the sign to cos, and the answer that we get is 3.0 0.216. So what's our coordinates for MP? We just say this plus this, this plus this. Our answer is going to be 224. Sorry, I forgot a negative here. I'm sorry. And then this one is also going to be negative 22408 point negative 22521.069 plus 112.879. The answer that we get 0.19. Same story here. This plus this, and our coordinates are 35186.625. So if you understand this, even now when you have moved on to the next section, you know the road continues, you can just apply these same things to get your answers. So just look at it. It's like this. I don't know if you can see it properly. And then this is the other page. Okay.